Imagine a world where extinct animals roam the earth again. Picture woolly mammoths lumbering across frozen landscapes and flocks of dodos waddling through tropical forests. What was once lost, now found. This isn't science fiction, it's the potential reality of de-extinction. Scientists are exploring the possibility of bringing back animals that are no longer with us. This incredible feat could reshape our planet and challenge our understanding of life and extinction itself. De-extinction is more than just reviving lost species. It's about restoring ecosystems, learning from the past, and understanding the power and responsibility we have in shaping the future of life on Earth. By bringing back extinct animals, we can learn valuable lessons about evolution, genetics, and the delicate balance of nature. The possibility of de-extinction raises profound questions. Can we really bring back creatures from the past? Should we even try? Join us as we delve into the science, the possibilities, and the ethical considerations of bringing extinct animals back to life. The journey promises to be as fascinating and complex as the science itself. De-extinction, simply put, is the process of bringing back to life a species that has vanished from the face of the Earth. This fascinating concept has captured the imagination of scientists and the public alike, as it promises to undo the finality of extinction and breathe new life into species long gone. It's like hitting rewind on evolution, giving extinct animals a second chance to exist. Imagine seeing a woolly mammoth roaming the tundra once more, or hearing the call of the passenger pigeon in the skies again. These are not just dreams, but potential realities that de-extinction aims to achieve. But de-extinction isn't about recreating the past perfectly. It's not a time machine that takes us back to the exact moment before a species disappeared. Instead, it's about using advanced science and technology to create animals with similar traits and genetic makeup to their extinct counterparts, blending the old with the new. It's about using science to create animals with similar traits and genetic makeup to their extinct counterparts. This involves a meticulous process of genetic analysis, where scientists decode the DNA of extinct species and compare it with that of their closest living relatives. Think of it like baking a cake. If you lose your grandmother's famous chocolate cake recipe, you can't recreate it exactly. But if you have a similar recipe and know what ingredients she used, you can bake a cake that tastes very close to hers. If you lose your grandmother's famous chocolate cake recipe, you can't recreate it exactly. However, with a bit of experimentation and the right ingredients, you can come very close. De-extinction works similarly, blending known genetic information with modern techniques to bring back something remarkably close to the original. But if you have a similar recipe and know what ingredients she used, you can bake a cake that tastes very close to hers. De-extinction works similarly. Scientists use genetic information extracted from preserved remains like bones, teeth, and hair to piece together the genetic blueprint of an extinct animal. Scientists use genetic information extracted from preserved remains like bones, teeth, and hair to piece together the genetic blueprint of an extinct animal. This genetic blueprint acts as a guide, helping them understand the unique characteristics and traits of the species they aim to resurrect. This information helps them identify living relatives with similar genes. By studying these relatives, scientists can fill in the gaps in the genetic code, ensuring that the new creation is as close as possible to the original species. By manipulating these genes, they can potentially create animals that closely resemble the extinct species. Techniques like CRISPR allow for precise editing of the genetic code, making it possible to introduce or modify specific traits that define the extinct species. De-extinction is a complex process, but the potential rewards are enormous. It could revolutionize our understanding of genetics, evolution, and conservation, offering new tools and insights for preserving biodiversity. It offers a chance to right the wrongs of the past, where human actions led to the extinction of many species. By bringing these animals back, we can restore lost ecosystems and learn valuable lessons about the impact of our actions on the natural world. It also provides a unique opportunity to study and learn from these magnificent creatures, expanding our knowledge of the natural world. De-extinction is not just about the past, it's about shaping a better future for all living things. At the heart of de-extinction lies the incredible molecule called DNA, the blueprint of life. DNA carries the genetic instructions that determine an organism's traits, from the color of its eyes to its size and behavior. Think of DNA as a long chain of instructions written in a special code. Each instruction tells a cell how to build a specific part of the organism. When an organism dies, its DNA gradually degrades over time. However, if the remains are preserved in special conditions like freezing or dryness, fragments of DNA can survive for thousands of years. Scientists can extract these DNA fragments from fossils and ancient remains. Extracting ancient DNA is like piecing together a giant jigsaw puzzle with many missing pieces. Scientists use sophisticated technology to read the genetic code within these fragments. Then, they compare these fragments to the DNA of closely related living species to fill in the missing gaps. By analyzing the genetic information, scientists can identify the genes responsible for specific traits of the extinct animal. This knowledge is crucial for de-extinction, as it allows scientists to select living relatives with similar genetic makeup and potentially manipulate their genes to recreate the extinct species. Section 4. How do we bring back the extinct? Cloning and beyond. The idea of bringing back extinct animals might seem like something out of a science fiction movie, but the science behind it is very real. Scientists around the world are working tirelessly to explore the possibilities of de-extinction, driven by the hope of restoring lost biodiversity and correcting past mistakes. There are several methods scientists are exploring to achieve de-extinction, and each comes with its own set of possibilities and challenges. These methods range from cloning to genetic engineering and selective breeding, each requiring a deep understanding of genetics and advanced technology. One method is cloning, a technique that creates a genetically identical copy of an organism. This process involves taking the DNA from a donor cell and inserting it into an egg cell that has had its own DNA removed. The egg is then stimulated to divide and develop into an embryo, which is implanted into a surrogate mother. While cloning has been successful with living animals like Dolly the sheep, it's much more challenging with extinct species. The primary hurdle is obtaining intact DNA, which is often degraded in ancient remains. Even if DNA is preserved, it may be incomplete or fragmented, making the cloning process extremely difficult. Cloning requires intact DNA, which is rare to find in ancient remains. Scientists often have to work with degraded samples, which complicates the process. Despite these challenges, advances in technology are providing new hope for overcoming these obstacles. Another method is genetic engineering, which involves manipulating the genes of a living relative to resemble those of the extinct species. This approach leverages the close genetic relationship between species to recreate lost traits. By editing the genetic code, scientists can introduce specific genes from the extinct animal into the genome of its living relative. This approach is like playing with the building blocks of life, editing the genetic code to recreate lost traits. It requires precise and sophisticated techniques to ensure that the inserted genes function correctly within the host organism. The potential of genetic engineering is vast, offering a way to bring back species that have been lost to time. Scientists can insert specific genes from the extinct animal into the genome of its living relative, essentially rewriting the genetic code to bring back lost characteristics. This method holds promise for species where cloning is not feasible due to the poor quality of available DNA. A third approach is backbreeding, a selective breeding process that focuses on enhancing specific traits in living descendants that resemble their extinct ancestors. This method involves identifying and breeding individuals that exhibit traits similar to the extinct species, gradually enhancing these traits over multiple generations. By carefully selecting individuals with desired traits and breeding them over generations, scientists can potentially recreate animals that closely resemble the extinct species. This method relies on the natural genetic variation within a population and the careful selection of breeding pairs to achieve the desired outcome. Each of these methods offers a unique pathway to de-extinction, bringing us closer to the possibility of seeing these lost creatures once again. Section 5. The Woolly Mammoth, a giant step back in time. The woolly mammoth, a giant of the Ice Age, is perhaps the most iconic candidate for de-extinction. These colossal creatures with their long, curved tusks and shaggy coats have captured the imagination of scientists and the public alike. Their story is one of survival and adaptation in some of the harshest climates on Earth. These magnificent creatures roamed the frozen landscapes of the Northern Hemisphere until their extinction around 4,000 years ago. They were well adapted to the cold, with their thick fur and layers of fat providing insulation against the frigid temperatures. Their presence was a testament to the resilience of life in the face of extreme conditions. Fortunately, their remains are well preserved in the permafrost, providing scientists with valuable genetic material. This preservation has allowed researchers to delve deep into the past, uncovering secrets that have been frozen in time for millennia. The discovery of these remains has sparked a renewed interest in the possibility of bringing these giants back to life. Scientists have successfully sequenced the woolly mammoth genome, revealing a wealth of information about its genes and evolutionary history. This genetic blueprint has provided insights into how these animals lived, adapted, and eventually went extinct. The sequencing of the genome is a monumental step forward in the field of genetics and de-extinction science. This genetic blueprint is crucial for understanding the mammoth's unique adaptations to cold environments, such as its thick fur, small ears, and layers of fat. These features were essential for their survival in the icy tundras, and are key to any efforts to recreate these animals today. By studying these adaptations, scientists hope to unlock the secrets of the mammoth's resilience. One approach to bringing back the woolly mammoth is through genetic engineering. This cutting-edge technology allows scientists to edit the DNA of living organisms, potentially enabling the resurrection of extinct species. The use of CRISPR technology has opened up new possibilities in the field of genetics, making the dream of de-extinction a tangible reality. Scientists are exploring the possibility of editing the genome of the Asian elephant, the mammoth's closest living relative, to introduce mammoth-specific genes. By doing so, they hope to create a hybrid animal that possesses the traits of the woolly mammoth. This approach leverages the similarities between the two species, making the process of de-extinction more feasible. By doing so, they aim to create elephants with traits that resemble the woolly mammoth, such as thick fur and cold tolerance. These hybrid animals could potentially thrive in environments similar to those once inhabited by the mammoths. The goal is not just to bring back an extinct species but to restore the ecological balance that was lost with their disappearance. The prospect of woolly mammoths roaming the Arctic tundra once again is exciting, but it also raises important questions. How would these resurrected giants impact the existing ecosystem? Would they compete with current species for resources, or could they help restore the environment to its former state? These are complex issues that require careful consideration. How would these resurrected giants impact the existing ecosystem? The introduction of a species that has been extinct for thousands of years could have unforeseen consequences. It is essential to study and understand the potential ecological impacts before moving forward with de-extinction efforts. The balance of nature is delicate, and any changes must be approached with caution. Would they be able to adapt to a world vastly different from the one they left behind? The modern world presents new challenges that the woolly mammoth never faced. Climate change, human activity, and altered landscapes are just a few of the factors that could affect their survival. Understanding these challenges is crucial for the success of any de-extinction project. These are just some of the challenges and considerations surrounding the de-extinction of the woolly mammoth. The ethical implications, potential ecological impacts, and the feasibility of such an ambitious project are all topics of ongoing debate. As science advances, it is essential to weigh the benefits and risks carefully. The journey to bring back the woolly mammoth is as complex as it is fascinating, and it represents a giant step back in time.